Hello guys, welcome back to Python Fundamentals episode 6. I am Aditya Thakur. Before we dive in, let's take a second to actually appreciate where you are right now because it's further than you might realize. You have installed Python and written your first program. You understand every code data type in integers, floats, strings, boolean, and how to convert between them. You know every operator Python offers and the exact precedence rules for evaluating complex expressions. You went genuinely deep on strings, which included slicing, methods, formatting, immutability. And last episode, your code learned to actually make decisions by itself, branching one way or another based on conditions. That's five full episodes of real substantial Python knowledge already in your hand. But here's the thing, every single program we have written so far has limitation in common. Every line runs exactly once, top to bottom, and then program ends. If you wanted to print something five times, you have had to write print five separate times. If you wanted to check 100 items in a list, you would have to write 100 separate checks by hand. That's obviously not how real software works. And today, that limitation disappears completely. Today, we are covering loops, for loops, while loops, break, continue, nested loops, and the small set of loop patterns that show up in almost every real Python program you'll ever write or read. I want to be upfront with you. This is a long episode, and it's generally one of the most important ones in the entire series. Loops are the tool that turns a simple script into a real program, something that can process 1,000 records as easily as it processes one, something that can keep running until a condition changes, something that can actually do work at scale instead of just executing a fixed list of steps once. A quick reminder on how to get most of this. Since it matters even more today than usual, code along with every single example. Don't just watch me. Type, pause, type it yourself, run it, see the output with your own eyes. And when we hit the practice problems through this episode, and there are five of them today, actually attempt each one before I reveal the solution. Struggling with a loop for 2 minutes teaches you more than writing the answer ever will. Here's exactly what we are covering in order: the for loop in full depth, looping over strings, lists, and even a preview of dictionaries, plus range, enumerate, and a few genuinely useful built-in functions that pair naturally with it. Then the while loop, condition-based repetition, and exactly when you should reach for it instead of for loop. Then break, continue, and a loop feature almost nobody knows about. The loops else close. And finally, nested loop, a loop inside another loop plus the handful of loop patterns you will use over and over again for the rest of your time writing Python, accumulating a total, counting matches, building a new list, finding a maximum, and flag variable. By the end of today, you will be able to process entire list of data, repeat actions a precise number of times or until a condition changes, and recognize the loop patterns that show up constantly in real code. So let's get into it. Let's start with the for loop, Python's tool for repeating an action once for every item in a sequence. Let's run this. Let's run this code. This is your first for loop. Let's run this. Later, and I have to add a string Python print later. Let's see what it prints. See, uh, a for loop takes each item from a sequence. Here, each character in the string Python, one at a time, and runs the intended block once per item. Six characters, six passes through the loop. Okay. Now let's read the syntax piece by piece. Uh, let's actually slow down and actually read this syntax carefully piece by piece. The word letter is what's called the loop variable, and importantly, the name is entirely up to you. I could have called it X or character or anything else. Python assigns it the current item on every single pass through the loop. The word it connects that loop variable to the sequence being looped over. In this case, the string Python naming your loop variable something meaningful, like the letter instead of X, makes your loops far more readable to anyone reading your code later, including future you. See, letter is a name you choose. Python assigns it the current item on every pass. Naming it something meaningful makes your loop far more readable. See, now let's loop over a list. Let's try out this question. Fruits, fruits equals. Let's make a list. Apple, comma, banana, comma, cherry, fruit and fruits. Print. What will print? Will print fruit. See, we got apple, banana, cherry. See, this prints apple, banana, cherry one per line. This is generally the most common use of a for loop in real code, processing every item in a list once at a time without manually tracking a position or an index. Notice I named the loop variable fruit singular while the list is named fruit, which is plural. That's really common and helpful naming convention. Now let's move on to range. Looping a specific number of times. Let's try this code. For I in range, what was the range? 5. Now print I. See, this prints 0, 1, 2, 3, 4, which is range of 5. It generates the number 0 to 4, 0 to 4, 5 which are 5 numbers in total, but stopping before 5. This is exactly like slicing, which you read in episode 4. The endpoint is exclusive. If you want exactly 5 numbers, range 5 gives you 5 numbers. They just happen to start at 0. Now let's move on to range with start and stop. Let's try this code. For I in range 2, comma 7. Print I. See, this prints 2, 3, 4, 5, 6, which was a range of 2 to 7, starts at 2 and stops before 7. And it is same exclusive and end rule and this same exclusive and end rule applies. This gives you full control over exactly where your counting begins and where it ends. Now let's move on to the next one. Now let's move on to range with a step. Let's try this code. For I in range 0, comma 10, comma 2, print I. See, this prints 0, 2, 4, 6, 8. Every second number. The third argument to range controls the steps. This this is the third argument in the range. This controls the step, meaning how much to add each time. Let's look at a negative step too. Let's look at a negative step. For I in range of 10 to 0, comma negative 1. Now print I. Let's run this. See, this counts down from 10 to 1. A negative step counts backward instead of forward, exactly like the step value in slicing that we have covered in previous episodes. Now let's move on to the next one. The next one is enumerate, getting the index and the value. Let's try this code. Fruits equals apple, comma, banana, banana, comma, cherry, for index, comma, fruit, and enumerate fruits. Now print index, comma, fruit. Let's see what it prints. See, this prints 0 apple, 1 banana, and 2 cherry. Without enumerate, if you wanted both the position and the value, you would have needed a separate counter variable that you manually increment every pass, messy and error prone. Enumerate gives you the position and the value all together in a clean way, in a single clean line. Let's move on to the next one. See, without enumerate, you would need a separate counter variable you manually increment. This gives you the position and the value together. Let's move on to the next one. The next one is looping over a dictionary. Let's try this code out first. What was the code? Person names and okay. Person. Let's write the dictionary name, then semicolon, then Sam, then age, then 25. For key, in person, print key, comma, person. Let's check what it prints. See, this prints name Sam, the age 25. Looping over a dictionary by default gives you each key one at a time, and you can use that key to look up the matching value. Okay, we'll cover dictionaries fully in episode 8, most probably episode 8, or I don't know in which episode, but I wanted you to see this pattern now since it directly builds on what we are covering today. Okay, now let's move on to the next one. Then see what is written over here. Looping over dictionary by default gives you each key. We'll cover dictionary fully in episode 8. Moving on to the next one. Next one is looping with zip. It prints two lists at once. So let's write this. Names equals Sam, comma, Alex, comma, Joe. Then what was that? The another list was scores equals 85, comma, 92, comma, 78. Now for name, comma score in zip names comma scores print f name score. Let's print this. See what we got. This prints Sam 85, Alex 92, Joe 78. The zip pairs up items from two lists by their position. The first item from names with the first item from score, and so on. This lets you loop over both lists together in a single clean for statement instead of manually indexing into both lists separately. Instead of like writing multiple lines of code using indexing, you can use this method also. Now let's move on to the next one. Next one is looping with sorted and reversed. Let's check this code first. Numbers. Wait. Numbers equals list of 5 comma 8 comma 1. Then for n in sorted numbers, print n. Then for n in reversed, then numbers, print one n को करवाना print. And let's check this result. See what we got. We got 1258, 1258. Then we got 1825. See, the first loop prints 1258, sorted smallest to largest number. The second loop prints 1825. That's the original list order, just reversed, not sorted. Okay. Here's the important part. Sorted and reversed don't change the original numbers list at all. They hand the for loop and reordered version to the like uh, they just hand the for loop and reordered version to literate it over, and numbers itself stays completely untouched. Now let's move on to the next one. See, sorted and reversed do not change the original list. They hand the for loop a reordered version to iterate over, leaving numbers untouched. Let's move on to the next one. Next one is a common mistake, modifying list while looping. Let's check this out first. Numbers equals 1, 2, 3, 4, 5. For n in numbers, if n percent 2 equals 0, numbers code remove n. And now let's check the answer. See, I want to flag this one specifically because it's a genuinely sneaky bug. Okay. Removing items from a list while you are actively looping over that same list causes Python to skip some items because removing an item shift every subsequent item's position, but the loop's internal position counter doesn't know that happened. The safe fix is to loop over a copy of the list instead of using numbers. That slice creates a fresh copy. Okay, so modifying the original doesn't interfere with the loop. Let's, let's see the next one. See, removing items from a list while looping over it directly causes Python to skip items. It shifts position from mid loop, loop over a copy instead for n in numbers, then slice over it. Here comes the practice question. It's the first practice question. So guys, just pause the video and perform the practice question by yourself. Then you can check the answer. What's the practice question? Using range, print every even number from 2 to 20 inclusive. Then using enumerate, loop over the list, red, green, blue, and print each color along with its position, starting the position count at 1 instead of 0. Let's check out the code. For in range 2 comma 21 comma 2, we have to print I, okay, as we have to print every even number from 1 to 20. It will print that. Then colors, we had the colors equals red, green, blue. Then just write for index, comma, color, and enumerate colors, uh, comma, start equals 1. Start equals 1. Then print index, comma, color. Uh, let's run the code. See, we got it. We got every like every even number over here. See, we got every even number from 0 to 20. Then we got this also, the position. See what happened. Range 2 to 21, step of 2, stops before 21. So 20 is correctly included. That's why we use 21, not 20 over here. And as the stop value, okay. That's why we used 21 as the stop value. And enumerate actually accepts an optional start argument, okay, letting you begin counting from 1 instead of default 0. It is extremely handy when you are displaying a numbered list to a user, okay. Now let's move on to the next one. Let's check the answer first. See, it's the same answer. See what's happening over here. Range 2 to 21. Step of 2 stops before 21, so 20 is correctly included. Enumerate accepts an optional start argument to begin counting from 1 instead of the default 0. That's what I told you. Now moving on to the next section. The next section is about while loop. While loop is Python's tool for repeating an action for as long as condition stays true. Okay. Now let's check your first while loop. Uh, let's just try this example first. Count equals 0. Then while count less than 5. Print count. Then we have to also write count plus equals 1. See, see what happened. This prints 0, 1, 2, 3, 4. Same output as our very first for loop example, okay? But it is built completely differently. While checks its condition before every single pass through the loop. As soon as counts becomes less than 5, becomes more than 5, and the condition becomes false, which happens once count reaches 5, the loop stops immediately, literally immediately. No more, no less. The loop will stop. Now let's move on to the next one. This is infinite loop trap. The next one is infinite loop trap. See, let's see what happens. Let's try this one. Then you'll get it. See, count equals 0 while count 5 print still going. See, I am not going to run this one live because it will run forever and it won't ever stop. Uh, so without something inside the loop, it will run forever and it won't stop. Without something inside the loop that eventually makes the condition false. In this case, forgetting to increment count. If you don't increment count, this loop will never stop. This is genuinely the single most this is genuinely the single most common beginner mistake. If this ever happens to you, just Control plus C in your terminal, force stop it. Just force stop it. Let's move to the next one. I have to erase it. I can't print this. Otherwise, the PC will crash. The next one is for versus while loop. When to use which? See, this is genuinely the single most useful rule of thumb in this entire episode. So I want to say it clearly. Use for when you know in advance exactly how many times you need to repeat something. Use while when you don't know in advance how much times you need this. Uh, when you need to keep going until some condition changes and you can't predict exactly when that will be, then you can use while loop. Now let's move on to the next one. Next one is the realistic example. Let's check this example. Countdown equals 5 while countdown greater than 0, then print countdown 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 minus equals 1. Now let's print lift off. Lift off. Let's see what happens in Python terminal. See, this prints 5, 4, 3, 2, 1. Then it lifts off. Then it print lift off. Okay, okay. A genuinely practical while loop example. The condition and the countdown variable works together naturally. The loop ends exactly when countdown reaches to 0, and then print outside the loop runs. Okay. Now let's move to the next one. The next one is also an example. Input validation loop. Let's test this example. Password equals, then while length of password is less than 8, password equals input enter a password and print password accepted. Let's check this out. See, enter password. See, this is generally a common real world pattern. Uh, it keeps asking the user for input until what they type satisfies some condition. Okay. Here we keep asking until the password is at least 5 characters long. The loop naturally stops when the condition is met. Okay. Now let's try next one. Next one is while true with a manual exit. Let's check this. While true. See, here the manual exit will be break. Okay, break condition. Answer equals input type quit to store. If answer equals quit, then break. Let's test this one first. Run Python file in terminal. See, while true, it creates an intentionally infinite loop. The condition is literally always true, so it would never stop on its own. Instead, you can control exactly when it ends. Using break, okay, which we are covering in full detail in a moment. Now let's move on to the next one. The next one is a realistic example based on a simple menu loop. Okay, let's try this example out in our VS Code. Choice equals empty string, then while choice is not equals to quit, quit, choice equals input command or quit. Print. Now using f string, right? You entered, then choice. Now print goodbye inside outside the loop. Okay, goodbye. Let's try this out. What happened? Oh, okay. In Python. Oh, 1, 2, 3. See, here we got this one. Okay, right? Command or quit. To quit, we have to write quit. Okay. See, after quitting the loop, we got goodbye as an answer. See, this is generally how simple command line works under the hood. Keep looping and reacting to whatever the user types until they explicitly signal that they want to stop by typing quit. Okay. Now let's move on to the next one. Now moving on to the next one. The next one is combining while with a counter and a flag. Let's test this example on VS Code. Attempts equals 0, then success equals false. Now while attempts less than 3 and note success, attempts plus equals 1 and success equals attempts, uh, which is equals 2. Now after that print f string attempts used, then attempts. See, we got attempts used 2. Notice the condition here combines two things with and. Okay, straight from episode 3. Attempts less than 3 and not success. This loop stops either after 3 tries or as soon as a successful becomes true, whichever happens first. This is a genuinely realistic pattern for something like a login system that gives someone limited number of attempts, like your Google or any mail. Let's move on to the next one. Next one is practice question. Just pause the video, try it by yourself, and then you can resume the video and check the answer. What's the question? Write a while loop that starts with a variable set to 100 and keeps dividing it by 2 and using integer division and printing the result, stopping once the value reaches 0. How many lines of output do you expect before it stops? Let's try this question. Value equals 100. We have to start from 100 now. While value is greater than 0, then we have to divide that by 2. Value, we have to get the floor division because we need the integer value. Now we can print value. Let's run the code. See, we got the answer 50, 25, 12, 6, 3, 1, 0. See, each pass halves the value using floor division, which we learned in episode 2. Since it's integer division, the value reaches exactly 0 after 7 steps, okay? And the loop then correctly stops. If you predicted 7 lines of output, you are thinking about the that this exactly right. Now let's move on to the next one. The next, let's check the answer first. See, value is equal to 100, while value greater than 0, value equals value floor division 2, print value. See, each pass halves the value using floor division from episode 2. Since it's integer division, the value reaches exactly 0 after 7 steps, and the loop then correctly stops. Now let's move on to the next one. Next one is the section 3, which is break, continue, and else. See, now let's get fine-grained control over exactly how a loop behaves using break, continue, and a genuinely and let's genuinely underused loop, which is else close. Okay, let's learn about that. The first one is break, exiting a loop immediately. Let's try this code first. For number in range of 10. If number equals 5, then we have to break the now print. Well, let's test this out. See what we got 1, 2, 3, 4. 0, 1, 2, 3, 4. See, this prints 0, 1, 2, 3, 4, and then stops completely, even through range of 10. Would normally go all the way to 9. The moment break runs, okay, Python exits the loop entirely when the break runs. It doesn't finish the current pass and it doesn't go back to check the loop's condition again and again. It just stops after the break condition gets the value. Now let's move on to the next one. Next one is a realistic break example, which is based on searching for a match. Let's test this one. Names equal list applying 8, then Alice, Bob, Sam, then Dana. Now list ends. Then target equals Sam. For name in names, if name equals target, then print found. Now print found. then break. Okay, let's test this one. See what found and then loop break. See, this prints found and then stops. Once you have found what you are looking for, there's no reason to keep on checking the rest of the list. Break stops that wasted extra work immediately, which matters a lot for performance once your list gets large. Okay, now let's move on to the next one. The next one is continue. Let's try this one. For number in range of 10, if number modulo 2 equals 0 is not equal 0, then continue. Print number. See, this prints 0, 2, 4, 6, and 8. Only the even numbers. Continue skips the rest of the current pass and jumps straight to the next item. Unlike break, the loop keeps running afterward, okay? It just skips this one specific iteration. It just skip that one. Now let's move on to the next one. The next one is difference between break and continue. See, look closely at the difference in output. What's the output? The break version prints 0, 1, 2, and then stops completely. 3 and 4 never even gets checked, okay? The continue version prints 0, 1, 2, 4. It skips 3 specifically, but then keeps going on and still prints 4. That's the core difference ends between break and continue. Break ends everything and continue just skips just one and then pass on. Now let's move to the next one. The next one is the else clause on a loop. Let's try this one. For number in range of 5 प्रिंट करेंगे हम number then else print loop finished normally. See, this prints loop finished normally. Okay. See, this will print 2, 3, 4, and then it prints loop finished normally. See, this confuses almost everyone the first time they say it. So let's be very precise. A loop's else clause runs only if the loop completes without ever hitting a break. Okay. It is rarely used in real code, but it's worth recognizing when you see it. After you see it, you won't be like confused at what happened here. Let's move on to the next one. The next one is why the else clause actually matters. Let's try this code and we'll find out why it matters. Target equals 99, number equals 3, comma 7, comma 12, comma 45. For n and numbers, if n equals target, print found it, and then break. Let's move to the next part, else close. Print not found anywhere. See, not found anywhere. See, this print's not found anywhere since 99 isn't in the list. Here's the genuinely useful pattern, else let you cleanly handle the like I searched everything and found nothing case without needing a separate found flag variable that you would otherwise have to create and check that afterward. If break does run, then the else block is skipped entirely. Like if break runs, else will be skipped. Here it didn't run, so we got the else value. Let's move on to the next one. Next one is continue inside a while loop. Let's try this one out. N equals 0, then while n less than 10, n plus equals 1. Wait, okay, my bad. N plus equals 1 if n percentage modulo 2, my bad. It's not percentage, it's modulo equals 0. Then continue. Then print and what happened? Let me wait. Let me check the error first. What happened? Okay, we got the answer. See, this prints the odd number 1, 3, 5, 7, and 9. Break and continue works identically inside while loops as they do in for loops, okay? The only difference is which type of loop is being controlled. The logic itself doesn't change at all, okay? There will be no change in logic. Both will be same as break and continue is in for loop as it is in while loop. Let's move on to the next one. Next one is a subtle bug, continuing skip and increment. See, I won't be running this code either because it creates an infinite loop. Here's exactly why. See, continue, jump straight back to the condition, check completely, skipping the n plus equals 1 line whenever n equals to 2, okay? So, once n actually hits 2, it gets stuck there forever, endlessly rechecking the same condition. The fix for this is, and this is generally important habit. The fix is to always make sure your increment happens before any continue that might skip it, or restructure the increment to happen unconditionally at very top of the loop. Okay, be careful about that. Let's move on to the next one. The next one is next practice round 3. Just pause the video, go through the question by yourself, then you can resume the video. Let's read the question first. Loop through numbers 1 to 20. Skip any number divisible by 3 by using continue. Stop the loop entirely using break. The moment you reach a number greater than 15, okay, print every number that wasn't skipped or the stopping point. Let's try the code for n in and in range 1 to 21. If n greater than 15, then break, and if n modulo 3 equals 0, then we have to continue, and then we have to print the n value. Oh, my bad. Small. Notice the break checks run first, okay? Before the continue check. That ordering matters. Number above 15, stop the loop completely before continue even gets a chance to run on them. If you would put the continue check first, it wouldn't change the final result here, but order absolutely can matter in other situations, okay? There will be change in order also. So it's worth being deliberate about it. Be careful. Let's move on to the next one. First, let's check the code. See. Now let's move on to the next one. Moving on to the next section and the last section, which is nested loops and patterns. Finally, let's cover loops inside another loop, plus the handful of loops pattern you will reuse constantly in real Python code. Let's move on to the first one. A loop inside another loop. Let's try this example. For I in range of 3, for j in range of 2, print कराएंगे हम I and j. Yes. See, this prints 6 line 0 0 0 1 1 0 1 1 2 0 2 1. For every single pass of the outer loop, the entire inner loop runs completely from start to finish. Three outer passes times two inner passes gives us six total lines printed. This is genuinely the core mental like model for nested loops. Okay, the inner loops finish fully before the outer loops move to its next value. It's as simple as that. Let's move to the next one. The next one is a realistic use based on the example building a grid. Let's test this example. For row in range 3, for column in range of 3 also. Print static comma end equals प्रिंट करवाएंगे खाली है. See, this prints a 3 by 3 grid of stars. Notice and this inside the inner print. That stops print from adding its default value, okay, into the new its default new line value. Keeping the stars on the same row separated by spaces. Then the plain print after the inner loop, but still inside the outer loop, moves us down to the next line before the next row starts. Now let's move to the next one. Next one is nested loops comparing two lists. Let's test this one. Colors equals first list आएगी red and blue. Then size is equals small m and l. For color in colors, for size in size and sizes. We have to print. Oh my god, there's a mistake over here. Let's correct this mistake. Print, then print using f string. Okay, color minus, it's not minus, it's hyphen, size. That's on the button code. See, see this prints every combination. Red S, red M, red L, blue S, blue M, and blue L. This generates every possible combination between the two lists. Okay, a generally realistic. This is a generally realistic pattern for building product variants, like an actual T-shirt stores color and size options. Let's move to the next one. Next one is break only exists the innermost loop. Let's test this code first. For I in range of 3, 3, then for j in range of 3, if j equals 1, then we have to break and then print I and j, print I comma j. See, this prints 0, 0, 1, 0, 2, 0. This generally surprises a lot of people the first time they see it. Break only stops the loop. It's loop, it is directly inside, meaning the inner loop here, okay? The outer loop keeps running completely normally, and then the inner loop restarts fresh from j equals 0 every single time the outer loop advances. Now let's move to the next one. See, it's the same. Next one is pattern accumulator. Let's test this example. Numbers equals 4 comma 8 comma 15 comma 16 comma 23 comma 42. Then total equals 0. Then for n in numbers, total plus equals n, print total. See, this is the accumulator pattern, and you will use this constantly in real code. Start a variable at a neutral starting value, which is 0. It makes sense for sums. Then update it every single pass through the loop. Okay, like in every single pass, you have to update the value. By the end, total holds the running sum of everything the loop has seen. Literal everything. This will hold the sum. Now let's move to the next one. Next one is pattern counter. Let's test this example. Words equals list cat, dog, cat, bird, and then again cat. Cat. Let's test the cat count. Cat count equals 0. काउंट करेंगे हम कैट कितनी बार कैट आ रही है इसमें. For word in words, if word equals cat, it will count now. Cat cat count plus equals 1. Now we'll print the cat count. See, this is very similar to accumulator pattern, but this one only increments when a specific condition is met, which is cat. This is genuinely exactly how Python built-in count method works internally under the hood, okay? It's just this loop pattern, okay? Already written for you. Let's move on to the next one. See, very similar to the accumulator, but only increments when a condition is met. This is exactly how count works internally under the hood. Let's move on to the next one. Next one is pattern building a new list. Let's test this example. Numbers equals लिस्ट बनाएंगे हम पहले 1 2 3 4 5 and then doubled equals empty list होगी इसकी for n in numbers. इसको append करेंगे हम फिर doubled dot append n star 2, then we'll print doubled. See, it starts with an empty list and then appends a transformed value on each pass. This exact pattern is going to reappear constantly once we cover list fully in upcoming episodes. This is generally one of the most important patterns in this entire episode. Like, this is one of the most important. Be careful. Now, let's move to the next pattern one, which is practice. Nested loop practice. Did, did I miss something? No. Just pause the video and go through the question by yourself. Then you can resume. Print a multiplication table for numbers 1 through 5. Each row should show one number. Numbers multiple. For example, row 3 should print 3 into 1 equals 3, 3 into 2 equals 6, and so on, up to 3 into 5 equals 15. Now let's test this question. Let's try this question. Okay. For row in range of 1 to 6, because we have to go to 1 to 5, skip 6 वाला तो skip ही हो जाएगा 4 colon in range of 1 to 6, ये भी हमने यही रखनी है range. Result equals row into colon and then print करेंगे हम h string row into wait row into colon equals result. Now we'll print the value. Print, प्लीज खाली रखेंगे print को. Result. See, this is the answer. See, the outer loops picks the row numbers and the inner loop cycles through every multiplier from 1 to 5. This is generally classic nested loop exercise and it touches nearly everything we have covered today. Okay. The next is structure, range with start and stop, and F string from episode 4. Now, let's see the answer. See, same answer. Now, let's move on to the next one. Next one is pattern finding the maximum manually. Now, let's test this pattern. Numbers equals 4 comma 19 comma 8 comma 42 comma 15. Largest equals number. Let's see, for n in numbers, if n greater than largest, then largest equals n कर देंगे हम. Largest equals n. Now outside the loop will print largest. See, we started by assuming the very first item is the largest you have seen. Okay. Then every time we find something bigger during the loop, we update our assumption again. By the end, largest genuinely holds the biggest value. And this is exactly how Python's built-in maximum function works. See, now let's move to the next one. Next one is flag variable. This oh, password equals ABC123. Now has digit equals false कर लेते हैं. 4 character in password. If character dot is digit, then hash digit equals true हो जाएगा. Then we'll print string यूज करके has a digit, has digit हो जाएगा. See, this prints has a digit equals true. A flag variable starts at false and then flips to true the moment something specific is found during the loop. Okay. This is extremely common in real validation code. Checking a password for a digit, checking a list for a specific item, all of it uses the exact same pattern. Now, let's move on to the next one. Next one is a triangle pattern with nested loops. Let's try this one. For row in range 1 to 5, 1 to 5, wait, 1 to 6 कर देते हैं, 6, 5 की चीज़. For star in stars range of row print star करेंगे print star end equals now we'll print खाली print डालेंगे. See, this prints a growing triangle, 1 star, then 2 star, then 3 star, then 4 star, and then 5. The key insight here is the inner loop's range depends on the outer loop's current value. Row controls exactly how many stars print on each line. Okay, growing by one with every new rows. Okay, now let's move to the next one. Next one is fifth practice round. Just pause this video and try this question by yourself, and then you can resume the video to check the answer. List, see the question. Given the list 12, 40, 45, 7, 23, 56, 9, 34. Use loop patterns from today to find the sum of all numbers. This is from accumulator. How many numbers are greater than 20? This is from counter. A new list containing only numbers greater than 20, building a new list. Okay. Use one loop per task. Let's check the answer. ट्राई करते हैं एक बार. Numbers equals 12, 45, 7, 23, then 56, then 9, then was 34. Now total equals 0 for n in numbers, total plus equals n. Then count करेंगे हम 0 for n in numbers, uh, if in greater than 20, count plus equals 1, then big numbers equals empty list डालेंगे. For n in numbers, if n greater than 20, big numbers dot append करेंगे हम n को. n. See, all three of today core pattern applied to the same data. The accumulator of the sum, counter with a condition for how many qualify, and building a filter list for the actually matching values. This trio genuinely covers the vast majority of real world loop problems you'll encounter. Hmm. Let's test it. See, this is the same answer. Hmm. Numbers list total equals 0 for any numbers, total plus equals 1 plus equals n. Then count for any numbers if n greater than 20, count plus equals 1. Big numbers equals. Okay. Now let's move to the next one. The next one is the main challenge. This is the main challenge of today's video. Please pause the video, try this question by yourself, and then you can resume the video. See, see, this will combine everything from today into one final challenge. So you should try this. L- Let's see the question. Given a secret number and a list of guesses, loop through the guesses. For each guess, print whether it's too low, too high, or correct. The moment a guess is correct, stop checking further guesses. If no guess in the list was correct, print out of guesses using a loop, else close. Let's test this one. Secret equals 42. Then guesses equals, guess डालते हैं कुछ भी, 10 डाल देते हैं, 20 डाल देते हैं, 50 डाल देते हैं, 40, 10, 100. For guess in guesses, guess in guesses, if guess less than secret, then print f guess too slow, too low, if guess secret, print f. Yes. Too high, then else, rent, string, uh, then होगा guess, correct guess. Then we'll break this. ऐसा लेते हैं. Out of guesses. Uh, Now let's trace this together. See, 10 is too low, 20 is too low, then 50 is too high, then 40 is too low, then 100 is too high, then we got out of guesses. See, what happens here? If something matches exactly over here, then it will print correct and then breaks fire immediately. So, see, and because break did run that loop, else close is skipped entirely. If it only would have printed out of guesses if like it printed here, like if we would have gone through every guesses without ever finding a match. This challenge genuinely uses every single tool from today's episode. For loops, if else elif from episode 5, break and the loop else close. Okay, now let's see the answer. C grade is 42 is the same. See, now let's move on to the next one. Here comes the recap part. Now, let's recap everything we have covered today. We covered four loops in full: looping over sequence, range, with start, stop, and step, enumerate for getting both index and value, and even previews of zip, sorted, and reversed. We covered while loops, condition based repetition, the infinite loop trap, and exactly when to reach for while instead of for loop. We covered break, continue, and we covered break and then continue and the loops often overlooked else close, okay, including a couple of genuinely subtle bugs to watch out for. And we covered nested loops, then here we covered grids, combinations, multiplication tables, plus the core loop patterns you'll reuse constantly, which were accumulator, then counter, then building a new list, then finding like a maximum value, and then flag variable. Now, in episode 7, we are covering list and tuples in full length, creation, every major list method, list comprehension, and slicing applied to list instead of strings. If today's building a new list pattern felt a little repetitive to type out by hand, you are going to love list, okay? You are going to love list comprehension. They are basically a one line shortcut for exactly that pattern, the same list pattern. So hit the subscribe so you don't miss it. See you in next episode. Bye bye.